Hi friends, I am Balaji Rao. Welcome to BR Max class. This is third class on matrices. Till now, we learned about matrix, types of matrices and solutions of exercise number 3.1 in NCERT textbook class 12 matrices chapter. This class, we will learn all theory part related to exercise number 3.2. In this theory part, we will learn algebra of matrices. Algebra of matrices means you know what I will say. What is algebra of matrices? Addition of matrices, subtraction of matrices, multiplication of matrices. Luckily, there is no division of matrices, right? All these things we are going to learn in this class. Addition of matrices. You observe here, addition of matrices. How addition of matrices is defined? How we add matrices. You see here, let A comma B are two matrices are of same order. A comma B are two matrices of same order. This is important. If A is 2 by 3 order, B is also of same order 2 by 3. You should consider the matrices are of same order. You cannot take A is one order, B is another order. You should take A and B are of same order. This is important. Then addition of matrices A comma B is denoted by A plus B. It is simple point only. What is the new thing in this? Addition of matrices A comma B is denoted by A plus B and is obtained by adding corresponding elements. While doing example, I'll explain this more clearly. By adding corresponding elements in A and B. Here two things you need to know. A and B must be are of same order and A plus B is obtained by adding corresponding elements in A and B. Now, we will try to understand this definition with an example. You see here, A is a matrix of order 2 by 3. Okay. B is also matrix of order 2 by 3. They are of same order or not? Yes, they are of same order. Very good. Now, addition of matrices is denoted by A plus B. How you will get A plus B? By adding corresponding elements. What corresponding element means? You see here first, this element is what? First row, first column element. Here also you take first row, first column element. You add them 1 plus 1. This is what element? This is first row, second column element. Here also you take first row, second column element. Corresponding element means like that. It can be understood easily. See 2 plus 0, 3 plus of minus 1, 1 plus 0, 3 plus 1, 1 plus 2. What I did here? I added corresponding elements in A and B. Okay, you just add them. 1 plus 1 is 2, 2 plus 0 is 2, 3 minus 1, plus of minus is minus, 3 minus 1 is 2, 1 plus 0 is 1, 3 plus 1 is 4, 1 plus 2 is 3. And important point, when we add two matrices, we will get a matrix that is also of same order. Try to understand. A and B are two matrices of same order. After adding the matrices, whatever you will get, that is also of same order you will get. See here, A is 2 by 3, B is 2 by 3, A plus B is also 2 by 3. I hope you are understanding. Good. It is easy definition, no need of much discussion. Now, we will learn properties related to addition of matrices. Properties. Okay. See these properties. First property, commutative law holds good with respect to addition. Commutative law means in functions chapter, you will learn binary operations. There you will learn commutative law. However, it is easy to understand. What I am trying to say, when you do A plus B, what answer you will get? When you calculate B plus A, then also you will get the same answer. So simply what we say that A plus B is same as B plus A. Okay. So with respect to addition, commutative law holds good. This is the first property. Associative law. What is associative law? See here, A plus B plus C equal to A plus B plus C. That is associative law. This can be verified very easily with an example. Okay. So if you calculate LHS, what matrix you will get? When you calculate RHS, you will get the same matrix. We use these things very frequently while doing objective questions. So you need to know this. With respect to addition, associative law holds good. What is associative law? A plus B plus C equal to A plus B plus C, right? And you see this is a plus O. O means 0 matrix. A plus O. O plus A is A. It can be understood easily, no need of much discussion, right? Okay. And you see here, A plus B equal to A plus C. You observe this left hand side part. Here A is there, here A is there. A plus B equal to A plus C. Here, in this result, left cancellation law holds good. That means when I take A to this side, A minus A will become 0 matrix. So, A plus B equal to A plus C, then I can write B equal to C. Okay. Now, similarly, A plus C equal to B plus C. You observe your right hand side, same matrix is there. So, right cancellation law also holds good. What I can write? I can write A equal to B. So, that is all about addition of matrices. What you learned about addition of matrices, sir? Yes? What you learned about addition of matrices? Can you say the definition? What is addition of matrices? Yes? Yes? Right. A comma B are two matrices are of same order. Then addition of matrices is denoted by A plus B and is obtained by adding corresponding elements in A and B. So you learned 5 important points related to addition of matrices. What are those? First point, A plus B is same as B plus A. Okay. Next point. Second point, associative law holds good. A plus B plus C is same as A plus B plus C. What is third point? A plus O. O means 0 matrix here. A plus O equal to O plus A equal to A. Okay. Fourth point, left cancellation law holds good. Fifth point, right cancellation law holds good. I hope you understand about addition of matrices. Now we will learn subtraction of matrices. This is also known as difference of matrices. Look here, difference of matrices or subtraction of matrices. This definition is also similar to last one only. A comma B are two matrices are of same order. They must be of same order. Then subtraction of matrices A comma B is denoted by A minus B. Subtraction of matrices A comma B is denoted by A minus B and is obtained by subtracting corresponding elements in A and B. What they are in this? It is similar to last definition only. Yes, it is easy definition. A comma, what things you need to remember here? They must be are of same order. A comma B must be are of same order. If they are not of same order, subtraction of matrices is not defined. Similarly, if A and B are not of same order, then addition of matrices is not possible. It is not defined. They must be are of same order. Okay. So subtraction of matrices. A and B must be are of same order. And how you will get A minus B? By subtracting corresponding elements in A and B. Okay. We'll try to understand this with an example. Right. You observe here, this is a matrix A, this is matrix B. You can see they are of same order or not. This is matrix are of order 2 rows, 3 columns. This order is 2 by 3. 2 rows, 3 columns. This order is also 2 by 3. How you will get A minus B? By subtracting corresponding elements in A and B. By subtracting corresponding elements in A and B. See here. 1 minus 1. You observe the corresponding elements. Here 1, here 1. 1 minus 1. Here 2, here 0. 2 minus 0. Here 3, here 1. Corresponding elements means I hope you understand. 3 minus 1. 4 minus of minus 1. 5 minus 2. 6 minus 0. Like that. 1 minus 1, 0. 2 minus 0. 2. 3 minus 1, 2. 4 minus of minus is plus. 4 plus 1 is 5. 5 minus 2 is 3. 6 minus 0 is 6. That's it. So it comes to properties almost similar to addition of matrices, but A minus B is not same as B minus A. When you calculate A minus B, B minus A, you don't get the same answer. A minus difference will be there, right? So other than that, we do not have much properties related to subtraction of matrices. Okay, now we'll move to next definition. Okay. Next definition. See here, what is this definition? Multiplication of a matrix by a scalar. Multiplication of a matrix by a scalar. This is not matrix multiplication. I'll multiply a matrix by a scalar. You try to understand what is this definition. First, you consider A is any matrix. You take A as any matrix. K is any scalar. Scalar means what? It is a constant, like 1. In physics, I think you already know about scalar. Constant we treat as a scalar. Here scalar means a constant number, right? K is scalar. That means K is any constant. Okay, K is any scalar. Then scalar multiplication of a matrix A is denoted by Ka. You try to understand. In this Ka, K is scalar, K is constant, and A is matrix. And Ka is obtained by multiplying all the elements of A with scalar K. You can understand how you will get Ka. Ka is obtained by multiplying all the elements of A with scalar K. For example, you see this example, the matrix A is like this, 1, 2, 3, 4, 5, 6, right? Whatever the order it is, A is any matrix. You take a matrix. You need 2A. You observe here, 2 is scalar, 2 is constant. How you will get 2A? Each element of matrix A you multiply with 2. See 2A, how you will get? 2 into 1, that is 2. 2A, here how you will get this 2A? 2 into 2, 4. This element you multiply with 2. 2 into 3, 6. This element you multiply with 2. 2 into 4, 8. 2 into 5, 10. 2 into 6, 12. Like that. How you will get Ka? Each element of matrix A is multiplied by K. I hope you understand how we will get Ka. This is the example 2A. Like that 3A minus A minus 2A. Minus 2A means minus 2 is scalar, A is given matrix. Like that we can calculate multiplication of a matrix by a scalar. Few properties are there related to this. Let's see what are those properties. Okay, you see this K into A plus B. What is K here? K is constant. K into A plus B is Ka plus Kb. It's simple only. A, B are matrices here. Okay, K is a scalar, constant. Constant into A plus B is what? Constant into A plus constant into B. Similarly, K1 plus K2 into A. Here A is matrix, K1, K2 are scalars, any two constants. Then you can write this as K1 into A plus K2 into A. These are simple things. With the examples you can check they are true or not. Okay. These results always holds good for any constant and for any matrix. Right. Okay. And you see this third property, minus K into A can be written as minus K into A, which can be written as K into minus A. A simple thing. If you take an example, you can understand these things. No need of much discussion of these things. But while doing objective questions in JEE, these properties will be useful, right? So, what are the things you learned till now in this class? We learn about addition of matrices. We learn about difference of matrices. We learn about scalar multiplication of a matrix, right? Addition of matrices is what? A, B are the matrices are of same order, and A plus B is obtained by adding corresponding elements in A and B. Difference of matrices, A, B matrices are of same order, then A minus B is obtained by subtracting corresponding elements in A and B. Next we learn multiplication of a matrix with a scalar. Scalar multiplication of a matrix. You take A is any matrix, K is any scalar. Ka is obtained by multiplying all the elements of A with scalar K. And we learn properties related to addition of matrices and properties related to multiplication of a matrix by a scalar. I strongly recommend you to take pen paper, write all these definitions, note down all these points. And don't forget to like a video because it gives me more energy to do many videos. Actually, these videos taking much time. And comment below and share these videos with your friends. Right. If you are not yet subscribed to my channel, please subscribe now. Now we'll move to very important definition. In the beginning only I am saying you may understand or may not understand this definition, but if you do 3 examples, at least 3 examples related to coming definition, then you can understand it easily. That definition is matrix multiplication. How we multiply 2 matrices. If A, B are 2 matrices, then how you multiply. See here, matrix multiplication. This is a little difficult to understand this definition, but what I will say, do not worry about the definition. If you do 2 or 3 examples, you will get more clarity. It is easy only, but the definition, it is difficult to understand. You see here what they given. A is a matrix. A equal to A is A, which is of order m by n they given. Actually, this is not full form of a matrix. This is one type of representation of a matrix. However, I written here what is that, and we discussed in class number 1. Okay, A is a matrix of order m by n. B is a matrix like this, Bij of order n by p. They given 2 matrices A and B. A is of order m by n. B is of order n by p. Then product of matrices A comma B is denoted by AB. Till now, what points you need to observe? A is a matrix of order m by n. B is a matrix of order n by p. Here you can observe, first matrix m rows n columns are there. This is important. First matrix, how many columns are there? N columns are there. Second matrix, you observe how many rows are there? N rows. Here n columns, here n rows, and p columns. What point you need to know here? To multiply 2 matrices, number of columns in first matrix must be equal to number of rows in second matrix. Otherwise, matrix multiplication is not possible. Matrix multiplication is not defined. I hope you are understanding what I am saying. To multiply 2 matrices, number of columns in first matrix, suppose you are calculating your AB, then number of columns in A must be equal to number of rows in B. Then only matrix multiplication is possible. Okay, so till now, product of matrices A comma B is denoted by AB, and to multiply the matrices, number of columns in first matrix must be equal to number of rows in second matrix. Here what I did, I written A. This is the matrix A na? I written full form of A. This we learn in class 1. Aij means ith row, jth column. This is first row, first column na? So this is A11. This is first row, second column na? A12. This is first row, nth column, because they given here n columns are there. A1n. This is second row, first column. That's why this is A21. This is second row, second column. That's why this is A22. This is second row, nth column. We know here n columns are there. Like that, last row. Here how many rows are there? M rows are there. That's why this is AM1. M1 first column, mth row first column, AM2 mth row second column, AMN. This is the matrix A. Similarly, I written the matrix B, B11. Why? Because this is Bij, B11. That means first row first column, B12 first row second column. Like that, how many rows are there in this? They given that n rows are there. See, nth row first column, nth row second column, nth row pth column, because p columns are there. I just written the matrix A and the matrix B. Now we will see how we multiply these matrices. What I am going to explain now, that is important. Please listen this carefully. Okay. We will find a trick to remember this. What is the trick? You see, what is this number? What is this number? Number 7. Okay. I am going to use this trick. Number 7. 1 minute. A trick that is called 7. See, 7 looks like row, horizontal line. This is column, right? What I will do first, first row, first column, like 7. See, like 7. Just, it is a trick. You consider first row in first matrix, first column in second matrix. Okay, like 7. Okay, what you do, multiply the corresponding elements and add them. Multiply the corresponding elements. A11, B11. Okay, next A12, B21. Don't take this one. A12, B21 plus I written. Multiply the corresponding elements and add them, and so on. Some other elements are there now. A1n into Bn1. I hope you are understanding what happened. This, can you tell what is this place? This is the place of first row, first column. Na? That's why here I considered first row, first column. That's it. It's very simple. Right? If you want this element present in which row, which column? This element present in first row, second column. First row, second column. So what you should do? You should consider first row, second column. That is also like 7. First row, second column. That is also like 7. I hope you are understanding. What you will do now to get this element, you consider the first row, because this is the first row, second column here, and multiply the corresponding elements and add them. See, A11 into B12 plus A12 into B22 plus and so on, A1n into Bn2. Like that, you take first row, third column, first row, fourth column, first row, fifth column. You can observe all like 7. Like that, first row, last column, first row, last column. See, this is the element present in which row, which column. And here you need to understand one thing. AB, when you multiply these two matrices, AB is a matrix is of order m by p. M by p. M by p. Okay. Now you observe, this is how you will get this. This is which row? First row. Which column? You can see here. This is which column? Pth column. So you take first row here and pth column here. You can see this is like 7. This is like 7. I hope you are understanding. This is like 7. This is like 7 only. So you take this first row and last column. What happened? So multiply corresponding elements and add them. A11 into B1p, A12 into B2p, A1n into Bnp, and you add them. I hope you are understanding. Like 7. First row, first column. Okay. Multiply and add them. Multiply the corresponding elements and add them. First row, second column. That's good. First row, third column. Like that. First row, last column. You multiply the corresponding elements and add them. That's great. Now, similarly, with now what happened? First row, all columns are over now. Now, second row, first column. You can see that is also like 7, but not exactly. I just using the trick for 7. Now you understand. No need of this 7 now. Okay. What I'll do now? Second row, first column. Second row, second column. Second row, third column. Like that. Second row, last column. Till that I'll do. Now see one example I'll take. Second row, first column. Multiply the corresponding elements and add them. A21 B11 plus A22 B21 plus and so on, A2n Bn1. I hope you are understanding. Like that I did all these things. Okay. Similarly, third row, first column, third row, second column, third row, like that. Here you come to the last row. What to do now? Last row, first column, last row, second column, last row, third column, last row, last column. Like that you need to multiply. This is the definition of matrix multiplication. Another version is also there. That is a little difficult version. In terms of representation, the definition is given in textbook. I do not want to confuse you. That's why I written definition in full form. Okay. Do not worry about whether you understand or not. Now I am going to do an example related to matrix multiplication. While doing exercise problems, you will get more clarity about matrix multiplication. And what things you need to remember. Here, in matrix multiplication, to multiply two matrices, number of columns in first matrix must be equal to number of rows in second matrix. That is important point. Okay. When you multiply two matrices, whatever the result you will get, whatever the answer you will get, that matrix is of order m by p. You see here, if this is m by n, n by p, then you will get m by p matrix. Okay, these are the points you need to keep in your mind. Generally, they don't ask define matrix multiplication. In case if they ask, you can write like this. Okay, now we'll do one example how we multiply matrices. Okay, you see this example. I considered the matrix A, matrix B like this. Then find AB. They are asking. First thing you need to check, matrix multiplication possible or not. Matrix multiplication possible or not. I written A here. When matrix multiplication is possible, 2 rows, 3 columns are there. Na? Number of columns in first matrix. How many columns are there in this matrix A? 3. Number of columns in first matrix must be equal to number of rows in second matrix. 1, 2, 3. Number of rows in second matrix. Okay. So here what I am trying to say, matrix multiplication is possible. Why? Number of columns, you look here, number of columns in first matrix equal to number of rows in second matrix. That's why matrix multiplication is possible. I written matrix A, matrix B. What I said? Remember the number 7. Okay, what is that number 7? First row, first column, it looks like 7. First row, first column. Multiply the corresponding elements and add them. See, or else you look here. This, to get this element, this is present in first row, first column. To get this element, you consider the first row, first column. Multiply the corresponding elements and add them. See, 1 into 3 plus 0 into 1 plus 1 into 2. I hope you are understanding. I multiplied the corresponding elements in first row and first column and then I added. I hope you are understanding, right? Now, to get this number, to get this element, this is which row, which column? This is first row, second column. Here you consider first row, second column. Or else simply first row, first column is over. Now first row, second column. 1 into 0 plus 0 into 2 plus 1 into 0. Okay. Now this, how you will get this? This is present in which row, which column? This is second row, first column. So here you take second row, here you take first column, multiply the corresponding elements and add them. 2 into 3 plus 0 into 1 plus 1 into 2. Okay. Now what is this element? This is the element present in second row, second column. So here you consider second row, here you consider second column. From first matrix you take rows, second matrix you take columns. Okay. 2 into 0 plus 0 into 2 plus 1 into 0. So here simplification done. 3 plus 0 plus 2, that is 5. Okay, now 0 plus 0 plus 0, that is 0. Okay, 2 3s are 6 plus 0 plus 2, that is 8. Okay, 0 plus 0 plus 0, that is 0. And you can observe here, this is AB na. You can observe here, this matrix multiplication is possible. After multiplying, whatever answer you will get, that will be of this order. See, 2 by 2, 2 by 2, right? That's great. We learn definition of matrix multiplication and we learn one example. It's better you take any 2 examples, try your own, then you will get more clarity. This is not difficult one, but many students will confuse unnecessarily. It's a simple one. Practice 2 to 3 problems. In exercise problems, I'll do a few more problems, right? Now we will learn important properties related to matrix multiplication. Okay. See, important. See this first property. What is the first property? AB, BA are same in general. Sometimes they may be same, but generally AB is not equal to BA. Take one example and try. AB, BA you calculate. They won't be equal. Rarely some chances are there they will be equal, but in generally AB not equal to BA. See, in algebra of matrices, addition of matrices, A plus B is same as B plus A, and A minus B not equal to B minus A. Here AB not equal to BA. Okay, associative law. See, associative law, second property, associative law. What is associative law? A into BC equal to AB into C, right? A into BC equal to AB into C. That is associative law. Like this works in addition of matrices also. A plus B plus C equal to A plus B plus C. Like that. Associative law holds good with respect to multiplication also. We use this result very frequently while doing JEE problems. A into BC equal to AB into C. And if you take identity matrix, A into I equal to I into A equal to A. Here, there in addition of matrices, A plus O means zero matrix, A plus O equal to O plus A equal to A in addition of matrices. In multiplication of matrices, A into I, here I means identity matrix. We learned what is identity matrix in class 1. A into I equal to I into A equal to A. Okay, this is known as distributive law. A into B plus C can be written as AB plus AC. A into B plus C can be written as AB plus AC, right? All these things we can verify with an example. Or else if it is like this, A plus B into C, that can be written as AC plus BC. Okay. Now you see this is a left cancellation law. AB equal to AC. You can observe here A is there. Then you can write B equal to C. So left cancellation law holds good. And BA equal to CA. Right cancellation law also holds good. Okay. And it is important. AB equal to 0 does not necessarily implies that A equal to 0 or B equal to 0. It's not compulsory. Any one of the matrices is 0, then only AB is 0. There is a chance both A is not equal to 0, B is not, A is not a 0 matrix, B is not a 0 matrix, then AB is a 0 matrix. There is a chance we will find such type of examples while doing second exercise in the NCERT textbook. And it's not implies both are also 0 matrices. Generally what point we will feel AB equal to 0 means either A equal to 0 or B equal to 0. But matrices it is not necessary. Right? If A is not 0 matrix, B is not a 0 matrix, there is a chance AB equal to 0. That we will discuss while doing exercise problems in second exercise. Right? So that's all about theory part related to second exercise. How you felt this type of videos? Just simply explaining the things. Just simply explaining the things for the written notes. You please comment below how you felt, if you need any improvement, if you felt that the class is fast, you please let me know, comment below, or the speed is okay, it's okay, and in the middle I am revising the definitions, is that okay with you, or you don't want that type of revision, let me know, right? Drop a like, it gives more energy to create many videos, right? And share this video with your friends. I am doing this just non-benefit. I'm not expecting any benefit from you. All these videos are free. I'm taking much time to create these videos. Just share these videos with your friends and subscribe to my channel. Have a great day. Thank you. Bye-bye.